Happy National Battery Day! Actually, I don't know if it's National Battery Day when you're watching this, but at any rate, it is around this time of the year, hopefully. Totally depends on when you're watching this, though. So we're in section 8.4, and this section is all about angles of elevation and angles of depression. So I'll write this on here. Section 8.4, if you're following along with the sections of the book. I can use angles of elevation and depression to solve problems. So these angles that we're talking about. All right, we're going to, this is just continuing in our study of trigonometry. So a couple words for vocabulary. First one is an angle of elevation. An angle of elevation is shown from this picture here. This is a great picture. It's an angle raised above a horizontal line. So it totally depends on this line of sight. Okay, you could argue one way or another depending on where you're looking, but it depends on this line of sight from essentially from where the person is or wherever you're talking about your vantage point. An angle of depression would be just the opposite, an angle raised or an angle below a horizontal line. So this line of sight is below the horizontal line, so it is an angle of depression. So I'd like you to take a look at these eight. It says describe each angle as an angle of elevation or an angle of depression as it relates to the diagrams below. So I want you to take a look at the diagrams and try to answer each of those eight, and then I'll show you what I got for each of those eight. So I'm going to pause. All right, so taking a look at these, I just labeled them as D or E for depression or elevation, and it looks like there's a pattern. So I'm looking at number one. This is the guy. This is the person, the vantage point. So if the horizontal line would be him looking straight across, angle one would be an angle of depression because it's below that horizontal line. Now number two and three are from this vantage point right here. Two is elevation because it's above, and three would be depression because it's below the horizontal line. And then finally, it looks like this is a swimmer or something. I don't know if this is a boat or a fish or what this diagram is, but number four is an angle of elevation because it goes above that horizontal line. Now looking at picture 2, 5, from the bird's vantage point, the line of sight would be below. So angle 5 would be depression. Angle 6 is this person right here. Looking up would be elevation. Looking down would be depression for number 7. And then finally, number 8 is looking up, so it's elevation. Now, how we can use those? Well, looking at number 9, 10, and 11, you might recognize these from the last section on trig ratios. So remember, SOHCAHTOA, SOHCAHTOA. So that'd be sine, cosine. So cosine would be ca, adjacent over hypotenuse, and toa would be tangent. So remember, sine is opposite over hypotenuse. Cosine of an angle is the adjacent over the hypotenuse, and tangent of an angle would be the opposite over the adjacent. So really, these are just examples of angles of elevation or depression. And to solve these, the missing pieces, you're just going to use sine, cosine, and tangent. So maybe we'll go through one or two of these to review. But if you look at like number 9, this is an angle of elevation. But we're trying to find x, which would be the adjacent side. And we have the hypotenuse. So adjacent and hypotenuse go with cosine. So the cosine of 13 degrees, excuse me, would be equal to the adjacent, which is x over h, which is 50. You can multiply both sides by 50. X is going to be by itself equal to 50 cosine of 13. And if you plug that into your calculator, which I have mine next to me, 50 times the cosine of 13 would be equal to 48.7. So it would be 48, x would equal 48.7 feet if I were to round it. And that looks about right. That looks right for that picture right there. Let's go to number 11 real quick. Let's do one of those, just a good recap here. We have the angle of 54, we have the hypotenuse, and we have the opposite. So sine of 54 would be equal to the opposite, so 38, over the hypotenuse, which is x. Now remember, when we solve for this, we multiply both sides by x, and then we still don't have x by itself, so then we have to divide. So we have to divide by the sine of 54 on both sides. So in other words, x is going to be equal to 38 divided by the sine of 54. And thanks to lovely calculators, we can figure out what that is. 38 divided by sine of 54 is 46. If you round it up, it'd actually be 47. So the hypotenuse would be 47, and I think that would be inches. And I can imagine that would be doable there. So there we go. So again, that's just a review of last time. But really the important things here are looking at these examples of real world problems where there could be angles of elevation or angles of depression. So let's take a look at number 12. It says a child is standing across the street from his apartment. His mother is on their balcony. So let's say this is the apartment building. This is a nice little balcony. This is the mother. She's got some long hair here. Alright, and the child is across the street. So this is the street. The child is right here. Got a little baseball hat on. Alright. The angle of elevation between the child's eyes and the mother's eyes is 22 degrees. If the distance between their eyes is 32 feet, how far is the child standing from the apartment building? So you got to know what an angle of elevation is. So you look from this child's eyes, this would be the horizontal, so the vantage point is going from the child's eyes to the mother's eyes. That's an angle of elevation. It's going up. And that angle is 22 degrees. Oops, 22 degrees. The distance is 32 feet. So how far is the kid from the building? That would be this x right here. So you can then set it up. If you know the picture, you can then set it up and use your trig ratios. So we have the hypotenuse and the adjacent. So that would be cosine of 22 would be equal to the adjacent k. So it would be x over 32. And when we multiply both sides by 32, x is going to be equal to 32 cosine of 22 degrees, which if we round to the nearest foot like we have to, 32 times cosine of 22 would be, rounded to the nearest foot, would be 30 feet. 30 feet from the building. So that's not too wide of a road, I don't think. Alright, I got a couple more word problems. We'll maybe do one of those and save the other ones for a different time. But let's look at number 13. A woman looks down from a hot air balloon. Ooh, hot air balloon. Here's my hot air balloon. Got the little things in the little basket. There's my hot air balloon. That's really bad, but you know what? There's a hot air balloon. She sees a sheep below and measures the angle of depression. That's impressive that she can measure the angle of depression, first of all. But if she's here, a measure of depression, her viewpoint is going across. Um, so you look at this woman, she's up here. This is her horizontal line. The measure of depression is the angle below that horizontal line. So if this is our sheep down here, I don't know how to draw a sheep. But the angle of depression would be this angle from here to here. This one is 35 degrees. And this is where it's important to know the difference between, what an angle of depression is. Most people would say it's just this angle underneath it. This is 35 degrees. But then by our situation, if the sheet is 125 feet from where the woman is looking down from the balloon, so this is 125 feet. How high off the ground is the balloon? So we're trying to figure out this distance right here. But in order to do that, this is our triangle sort of thing, we need to have the angle that's inside of that triangle. So this would be 90 minus 35, so that would be 55 degrees, sorry. So this is the important angle, the 55-degree angle. But we're only given the angle of depression, so that would be the 35 right there. So that is a important talking point, important thing to think about as we're making these situations and we're looking at those. So if we have 55 degrees, we have the hypotenuse and the adjacent again. This would be cosine, because that would be the cosine of 55 equals the adjacent over the hypotenuse. And we can then solve um, for x by multiplying both sides by 125. So x is equal to 125 times the cosine of 55, which is equal to, according to my calculation, 71.7 feet. So that hot air balloon is 71.7 feet off the ground. What I like to do is decide between number 14 and number 15. Pick one of them. It doesn't matter which one. They probably both have similar difficulties. Um, Try one of those and come with one of those to class next time, and then finish with the closing questions if you could. All right. Hope you learned something here with angles of elevation and depression. Really being able to just look at a situation and understand what the elevation, what would be the angle of elevation, what's the angle of depression, and figuring out that situation. All right, that is all. We'll see you next time.